Anybody, how many degrees? All the angles add up to 180. Yep. You have no idea how much you're going to learn this unit and next unit about the triangle, because that's all we're studying. This unit and next unit is the triangle. Today, though, I'm going to take it nice and easy on you. We're going to name the types of triangles. Okay, we're going to name all the different types of triangles. First ones I want to go over are based on its side lengths. How to name a triangle based on its side lengths. So if all the sides are congruent, the same length, anybody, let's have a little challenge here. Anybody? All three are the same. I call that a equilateral triangle. Yes, that's a good. Equilateral is a nice honors geometry spelling bee competition word. All right, before break. Equilateral. What about if only two are congruent to each other? Two. Hi, Grace. Isosceles. Another spelling bee word. Isosceles, nice. And what if I don't have any sides equal? Hi, Maddie. Scalene. Yes, scalene. So I think you guys are familiar with those. So that's how I can name a triangle on its side lengths only. Side lengths only. All right, what if I don't know anything about the side lengths, but I do know something about the angle measures? Everyone see, I got all three angles congruent there. Ooh, not too many people know this. You could still call it equilateral, because if all the angles are equal, that means all the sides are equal. So yes, technically equilateral, but there is another name. Ready for this one? Let it roll off the tongue. Equiangular. Equiangular. I get a couple chuckles out of that one, yeah? Equiangular. Angular. Equiangular. Again, you could also call it, I'm not going to say you're wrong if you say equilateral, because it is. All right, now I have a 105-degree angle there. Doesn't matter what the others are, trust me. If I have a 105-degree angle, anybody know what I call that triangle? Come on. Come on. What type of angle is 105? Bigger than 90. So I call this an I knew that. I just didn't want to say it. Yeah, okay. Obtuse triangle. This is obtuse. If it's got one angle bigger than 90, obtuse. Well, Mr. Carlino, what if it has two angles bigger than 90? That's impossible. Okay, because they only can go up to 180, right? So we only can have one. Okay, how about this next one? Let's go. Right triangle. Oh, everyone chimes in now, huh? All right. And then I gave you 70 and 30. You can find the other angle if you want, 80, but what type of triangle do I have here if all of them are less than 90? Acute triangle. Yes, acute. Good work. So that's how I can name it based on its angles. So a little bit new vocabulary, some old. Any questions on their names before we start working with them? I think you guys are going to have plenty of opportunity today to start the assignment, maybe even finish it. All right, I definitely want to mix in what we've been working on in the past 3 units. M is the midpoint of JL, so we should know something there, right? Let me actually start with you guys by calling on you. If M's the midpoint of JL, M is the midpoint of JL, tell me something about that diagram. M is the midpoint of JL. What can you tell me from that given piece there? We got 3 spot. Hi, Niara.
It bisects JL.
Okay, well, tell me more. What pieces are equal then? We should know what 2 segments are equal then.
J and K, and is that even?
What's getting bisected, a segment or an angle?
No, I meant JM is equal to JL.
JM and JL?
I mean ML.
ML, all right, good, we got there. Okay, so I know those two are equal. Good. Boom. And do you see in the givens, I also told you Km and ML were equal. I marked that on the diagram myself to give that to you. Now do you see all three are equal? Okay, we all at that point, all three are equal. Is this triangle going to be equilateral? JKM. So JKM, is that triangle going to be equilateral, isosceles, or scalene? Or scalene. What do we think here? JKM. This triangle right there, JKM. What type of triangle is that going to be? Let's work through it with me. I know one side is a length of 0.75. Can you find other sides, please? Can you? Can we find other sides? Talk to me. Any other side lengths we could find? 8. Oh, Grace, look at that. Hand up already.
So you take half of 1.5.
Why half?
Because that's the definition of
Darn. Hey, guys, I don't know anything about this. Grace and I can't talk about this. All right, so yes, because I said M's the midpoint, JM and ML are equal, so cut it in half.
And so whatever JM is, it's also what KM is, because KM is equal to ML and ML is equal to JM.
So a couple substitutions, they're all equal. So what's each side here? Because you're going to take half of 1.5 for me.
It's 0.75.
Okay, teamwork, right? 0.75, 0.75. Everyone see how we got to 0.75 for all three sides? All right, now answer the question. What type of triangle is J, K, M now based on those three sides? 1, Eric, what do you got? Equilateral. And then back yourself up, Eric. How do you know it's equilateral? Yep, because all sides equal or all sides congruent. All right, nice little problem right there. Nice little problem. Questions from you guys? Matt, how'd that look? Good. Any issues? Lucy, you good? Darn right you are. Example 2. Find the measures of all the sides of this isosceles triangle. I'm trying to set you up for a trap. Okay, hold on. Don't try to write anything down yet. Let me just show you the huge no-no, what's going to drive me nuts. This right here, when kids add up all three sides and set it equal to 180. What's 180 for? For the angles of a triangle, not the sides. All right? So just because I gave you all three sides, does that mean you need to use all three sides? No. No. All right? If you use 180, it better be for the angles. Don't touch 180 if it's for the sides. Now, I did give you all three sides. Do I need them, though? No, I don't. When I set up the equation, what are the only two sides you know are equal up here?
4.
Relax.
4x plus 1 and 5x minus 1.
So look, guys, 4x plus 1 is equal to 5x minus 0.5. I don't need to involve 9x minus 1. I know some of you seen it. I got to use it. No, you don't. We are actually going to use it, but not until the end of the problem. But to solve for x, I don't need it. Are we all good there? All right, why I'm not using 9x minus 1 in my equation. I'll still use it at the end to figure out how long it is, but not now. So go ahead, everyone, solve for x. I'll be with you in a minute. When you get x, let me know. Maddie, when you get x, let me know.
I got it.
Okay.
I think it's 1.5.
I think you're right. 1.5. And then you guys get in this bad habit on your quiz and test. Oh, I found x. I'm done. Yay. I feel so good about myself, but you're going to get points off. Find the sides. Find the sides. So now plug it back in. Find AC, BC, which should be equal to each other, hopefully, when you plug in 1.5. And then this is why I needed the 9x minus 1, because I do need to find the side length of AB. Chloe, take your time. Whenever you're ready, let me know. Take your time.
Okay, so the first two are both 7.
They better be, right? They better be congruent because it's isosceles. And how about AB?
12.5.
What is it?
12.5.
Yep. Good work. Any question? Am I going too fast? Or are we all right? Are we okay on why I set the equation up like I did? And I did not involve 9x minus 1. You don't need to. Okay? You don't need to. And then the final one. You're not going to be happy about this, but you are in honors, so you can suck it up. Ooh, what type of triangle is this on a graph? So I'll give you a minute. Go ahead and graph DEF for me. Label it. Come on, label it. DEF. Where's your labels? Come on, you're better than this. What type of triangle is that? I have no idea. I need to know something about the side lengths, right? To figure out if it's scalene, isosceles, or equilateral. I need to know what the side lengths are. Can you guys help me out? Is there anything we have available to us that'll find the lengths of the sides? Oh, my heart just dropped.
Distance formula.
Subtract.
No, I said the graph.
How are you going to do that?
I don't know.
Okay.
It's just guess.
I do need the graph, yeah, but.
It's
Oh, there it is. Wow. Niara, thanks for the contribution. What is it? No. What did you just say? I'm not.
distance formula.
Yeah, everyone remember from Unit 1, our good old distance formula will find the length of a line segment? Yeah, distance formula. Uh-oh, anybody want to take a stab at it? It's been a while. It's never going away, by the way. Never going away. Oh boy, here we go.
X2 minus X1 squared.
Whoa.
Plus Y2 minus Y1 squared.
Look at you. Showing off. Yes, the old distance formula. Great work. Great work. I will do one with you, and then you're on your own for the other two sides there, kids. Anybody want to have a preference? Yeah, you gave all that. You tell us which one we want to find together.
E. DE.
DE, you got it. So everyone, let's find DE together. Whoosh. Okay, DE, give me the old X coordinates for D and E. Order doesn't matter for distance. Oh, 5, I don't think we have one. 8, we got an 8, don't we, Grace? How about the X coordinates for D and E?
2 plus 5.
2 plus, everyone all right? Why she's rolling out the plus? Negative minus a negative 5, 2 plus 5 all squared plus. How about the Y's for D and E? 10? Nope. Come on, 5. Yep, come on now. 6? Hi. I like how you pointed like that's me. Yeah. Like I don't know my numbers. What is that?
1 minus 9.
1 minus 9, yep. All squared. All right, what do we have inside now? I got 7 squared, 49. And I got negative 8 squared, 64, yep. Remember, after you're done squaring, hey, remember, after you're done squaring, these numbers never negative, always positive, always. All right, let's add them up. What is that? The square root of 113? You know, anybody know what I'm going to say next? Because you're in honors.
Wait, and since
Put it in simplest form if you can, yes. The question is, can I? Is there a perfect square that goes into 113? Remember our perfect squares? 2 squared, 3 squared, 4 squared, 5 squared, right? 4, 9, 16, 25, 36, 49, so on, so on. Any one of those go into 113? Evenly. No? No, it doesn't. So that's it right there. Okay. I'm not going to say that's the case for the next two, but you can find out on your own. Work with people around you. Go ahead and figure out what FE and ED. I'm sorry, we already did that one. So DF and FE. Go ahead. You got it. You got it. And I'm just letting you know, these two you're finding now can be broken down. They can be broken down. Those last two should be able to be simplified. And it's okay. Oh, my heart. Never negative. You gotta remember, you square a negative number, it's always positive. Come on, you're better than that. So, not adding, multiplying. Right? You can't, when you break it down, we don't add them together. So I need a number that goes into 104 evenly. Okay, we don't add them together. Okay. Okay, let's talk. And don't get nervous or upset or frustrated if you're having trouble breaking it down. That's not a big deal. You'll get plenty of practice in this unit. DF, I am getting square root of 45. Before I break it down, square root of 45. Do we want to see how I got square root of 45? Are we good? 36 plus 9. So you should have 6 squared and 3 squared. Or negative 3 squared, negative 6, whatever, but you square either one and you get 36 and 9. Gives you 45. Ready? Now I break down 45 into 2 radicals. One of them is the biggest perfect square up here that goes into 45 evenly. And that would be 9. 9 goes into 45 evenly, goes in 5 times. I'm always multiplying. Square root of 9, 3. Square root of 5. So that's what 45 is broken down. We okay? FE, I have 10 squared and 2 squared. Some version of 10 and 2 squared, positive or negative. So I ended up getting the square root of 104 out. Square root of 104. That can be broken down because 4 goes into 104. 4 is a perfect square. It goes into 104. You multiply it by what I multiply by? 26. Yep. Multiply it by 26. So broken down, simplest radical form, 2. Square root of 4 is 2. Radical 26. So here are all 3 sides. What type of triangle do I have then? Okay, what type of triangle? If those are my 3 sides, the equilateral, isosceles, or scalene. What type of triangle do I have now? Here you go. 8. Grace, what type of triangle? Scalene. Why do you say scalene? Correct. Triangle DEF is scalene because no sides are equal. All right. I believe you have one tonight that's like this, and I do ask for simplest radical form, as you can see on your bottom of your page, what the homework is, which you can get going on now. You got plenty of time, 15 minutes left in class today. You can work with it on other people, move around, put your desk together. Go ahead and work on the assignment with other people.